this is the reaction of benzaldehyde with ethylene glycol under acidic conditions. And I already pre-made the drawing so that I don't spend too much time per se. So here I go. So first, the aldehyde is activated when when the oxygen is protonated under acidic conditions. And then the electrophilic carbon of the aldehyde carbonyl is attacked by the lone pair of the ethylene glycol, which causes the double bond here to break, which gives us a tetrahedral intermediate, as we can see here. So another molecule of the ethylene glycol will act as a base. The lone pair of the oxygen will attack to remove the hydrogen, which then will lead to the protonation of the positively charged oxygen, as shown here. The ethylene glycol that took the hydrogen is now protonated, and the hydrogen taken from the protonated alcohol is transferred to the OH group. Like that, it becomes a good leaving group, which, as we may know, the leaving group will be water. You can see. So a lone pair from the oxygen is taken to form a pi bond in order to kick out water, as you can see here. So here it's taken, then water is kicked out like this. So when the water molecule is eliminated by the non-bonding electrons of the adjacent oxygen, it gives the very electrophilic species we can see here. And then an intramolecular nucleophilic attack by the terminal hydroxyl group results in the formation of the 5-membered ring, as you can see here. And then in this final step, we can see that the same water that is eliminated may deprotonate the positively charged oxygen here, which would form our acetal final product that we want here. You can see here the lone pair of the oxygen attacks the hydrogen, which would give us the acetal. So that's what is going on: activation under acidic conditions, attack of the electron pairs in oxygen from the ethylene glycol to the electrophilic carbon of the aldehyde carbonyl, break of the double bond, tetrahedral intermediate. The ethylene glycol attacks the hydrogen, it removes it. And then here, what occurs again is the hydrogen is not protonated, as I mentioned, and the hydrogen is taken from the protonated alcohol, which will be transferred to the OH group, and then that will become into water, as I mentioned, which will be eliminated, give us this electrophilic species. And then the same, this here will cause the formation of the 5-membered ring here, 3, 4, 5. And then the same water that's eliminated will attack the hydrogen, which would cause the formation of our acetal since it's being protonated. And that's it.